Factor labeling worksheet number 1. The first problem reads, a gas at 25 degrees Celsius exactly fills a container previously determined to have a volume of 1.05 times 10 to the third centimeters cubed. The container plus gas are weighed and found to have a mass of 837.6 grams. The container, when emptied of all gases, has a mass of 836.2 grams. What is the density of the gas at 25 degrees Celsius? 25 degrees Celsius is just there to tell you that it's the same, so there's no change in volume. Alright, so we're going to start with density is equal to mass divided by volume. So what is the mass of the gas? It's 837.6 grams minus 836.2 grams. Divide this by 1.05 times 10 to the third centimeters cubed. So we subtract and we get 1.4 grams, and this is 1.05 times 10 to the third centimeters cubed, and we just plug that into the calculator and we get 1.30 times 10 negative second grams per centimeters cubed. Alright, I'm going to leave you number 2 to figure out by your own. So it's on your own. Number 3. Number 2, I would like to know your reasoning. The answer key online tells you 3 or 5, and I want to know what you think. Alright, number 3 reads, you are approaching a city and the sign indicates a speed limit of 40 kilometers per hour. What is the corresponding speed in miles per hour? So we're going to start with 40 kilometers per hour. It's 1 hour. We're going to convert that to miles, and miles are equal to 1.60934 kilometers. Kilometers cancel out. We're left with miles per hour, and we do 40 divided by 1.60934, and we end up with 24.854. We don't travel at 24.854 miles per hour, so we do about 25 miles per hour. Number 4, you have to pour 2 cubic yards of concrete for a patio. What is the volume in cubic meters? So I know that 1 yard is equal to 0.9144 meters. I don't want this regular, I want this cube, so I'll put this cube and I'll put this cubed. So I do 1 times 1 times 1, and that is 1 yard cubed. And now I'm going to do this times itself 3 times. I'm going to end up with 0.764 meters cubed. And I don't just have this once, I have this twice, so I'm going to multiply that by 2 times, and I end up with 1.5 meters cubed. Number 5, it asks for the density of mercury, which is 13.6 grams per centimeter cubed, but it wants it in kilogram per meter cubed. So I'm going to do some transfers. I'll convert 13.6 grams per centimeter cubed. Convert this to kilograms, so 1 kilogram is equal to 10 to the third grams. And now I have I'm going to transfer this to meters, so now get rid of centimeters, and I have meters. I want, in 1 meter there's times 10 to the second centimeters, and I want this cubed. The whole thing is cubed. And I work that out. By the way, 3 cubing the times 10 to the second would give us 6, an exponent of 6. So we work this out. In the calculator we get 1.36 times 10 to the 4 kilogram per meters cubed. The centimeters cancel out. The grams cancel out. I'm left with kilogram and meters is cubed. Okay. Number 6. 1 quart is equivalent to 0.946 liters. Calculate the number of liters in 10 US gallons of gasoline. So I have 10 gallons of gasoline. I have 4 quarts per gallon. Gallons will cancel out. I'm left with quarts. In 1 quart, I have 0.946 liters. Quarts cancel out. And I'm left with liters, which is what I want. So I'm going to do 10 times 4 times 0.946. That equals 37.8 liters. Number 7. The acid in an auto battery has a density of 1.2 grams per milliliter. What is the mass in grams of 2 liters of the acid? Again, density is equal to mass divided by volume. 1.2 grams per milliliter times 10 to the third milliliters in every 1 liter. Milliliters cancel out. I am then left with 1,200 grams per liter. So that is my density. I have 2 liters and I don't have my mass. So then here I'm going to get rid of this 2. So I'm dividing, so I'm going to multiply by 2 on both sides. So now I have 2,400 grams per liter. And liters canceled out, so 2,400 grams. 8. What is the volume in liters of 2 kilograms of aluminum if it has a density of 2.70 grams per centimeter cubed? So I have 2.7 grams per milliliter. Remember that milliliter is the same thing as centimeters cubed. I'm going to transfer this to liters. So I'm going to do times 10 to the third milliliters for every 1 liter. Milliliters cancel out. And I'm going to transfer my grams to kilograms. 1 kilogram is equal times 10 to the third grams. Grams cancel out. I run this straight through. 2.7 times 1,000 divided by 1,000. 2.7. There's a mistake in the key, by the way. I just noticed it. Kilogram per liter. The key says 2.3. I don't know what I did that. So that is my density. It's asking for the volume. I know the mass, so I'm going to do 2 kilograms. And I do not know my volume. So I want to get volume on its own, so I'm going to multiply by volume on both sides. So as to have, it's going to cancel out, 2.7 kilograms per liter times the volume, which is equal to 2 kilograms. I want to get rid of 2.7 kilograms per liter, so I'm going to divide this by 2.7 kilograms per liter. And on this side also. So now this cancels out. I'm left with the volume equaling 2 kilograms divided by 2.7 kilograms per liter. Kilograms cancel out. I now have volume like this. And I'm dividing by it, so it's going to do a reciprocal. So now my answer is going to be in liters. And when you divide 2 by 2.7, 2 divided by 2.7 is equal to 0.74 liters. So that's my new volume. All right.